Hi everybody, I welcome you again on my channel. I'm Dr. Tuti. I am Dr. Huseynova and I'm going to talk today about the guidance from study design to statistics. I don't know, but I never had any courses or statistical education when I started my research fellowship, but later when I was working with the data, I understood how important it is actually to have some statistical overview before you start writing an article. And it took me quite some time until I got all the necessary information, all the necessary books, and I'm really grateful to my supervisor at that moment who provided me with all necessary books and materials which I needed, and also additional some information from the internet which helped me also a lot. But in this presentation it's like an overview and summary of everything which I have read, but not of course in all details, but as a basic information which will give you some overview about statistics before you start writing. And believe me, it's not that scary how it sounds, and I will try to explain it in this presentation as easy and simple as I can. This presentation consists of two parts, but it's going to be in one video, and in the description section I will just write which part is at which moment and minute the second part starts, so you can start your second part whenever you want after you watch the first part. So let's start with the first part of this presentation. So first part is about planning studies from design to publication. Organizing a study. There are stages of scientific knowledge, where on first stage you have to describe the scientific knowledge, on the second explain, and on the third predict. There is a science underlying clinical decision making. So when we write any science or prepare any scientific project, there is a scientific method and evidence, because medicine is an evidence-based medicine we have. Why do we need statistics? Statistics measures and control uncertainty, clarifies our exact question, identifies the variable. When I talk about variable, I mean the parameters which we show in our projects, which actually plays a vital role of our study project. Then why we need statistics? It verifies that the planned sample is adequate, and test the sample and answer the question asked. There are also study types. I'm sure most of you, when you were reading any medical articles in ophthalmology journals, you end up with different types of studies. In one article you have read that this study is a case control study or cohort study. So, case control study or randomized study is a study in which an experimental group of patients is chosen for being characterized by some outcome factor, such as having acquired a disease, and the control group lacking this factor. For example, when you compare key parameters of keratoconus patients and normal eyes. So this is going to be a randomized case control study. Cohort study starts by choosing groups that have already been assigned to study categories, such as disease or treatments, and follows these groups forward in time to assess the outcomes. The key determinant is this sequence in which the risk factor or characteristics and the disease occurs or condition. There is also case control contrasted with cohort studies type of publications and works. Randomized control trial, RCT, or clinical trial, is a true experiment in which patients are assigned randomly to a study category, such as clinical treatment, and are then followed forward, making it a prospective study, and the outcome is also assessed. And the comparative studies, when of course you have for example, two kind of treatments and you compare the outcome. So it's going to be a comparative study. How to plan and conduct a study? There are following steps for that. Step number 1, start with objective. Step number 2, develop background. When we talk about starting with objectives and developing background, we mean basically our thoughts and what exactly we want to show in our study design and study project. Step number 3, plan your materials. When you know already what exactly you want to show in your project, you start to prepare all the necessary materials. It might be the patient's information, the parameters which you want to describe, and all the necessary materials you need. Step number 4, plan your methods. Methods and materials are for their describing the core of your study project. That might be, for example, if you describe parameters for corneal biomechanics, you're gonna use all parameters from devices which are helping you to measure corneal biomechanics. Step number 4, plan your data. Step number 6, define subjects population. You have to know how many patients you want to include in your study in order to have a reliable statistical analysis and calculation. Step number 7, anticipate a statistical analysis, which I just mentioned. Step 8, plan your conclusion. Step 9, anticipate the form of your conclusion. So these all steps you have to already have in your mind and have prepared when you already start to plan and conduct a study. Only after having and passing all these steps you can start writing an abstract. Second part of this presentation, what do I do with my data? How to manage data? As I said, first is making a plan. Making a plan reduces errors, work, and time spent. Assess what you have for raw data and what you want to finish with, and plan how to get from the former to the latter. Raw data. What is raw data? Raw data may be in patients' charts or even scattered among charts, lab reports, and service sheets. So it's basically all the information or all the parameters which you're going to include in your study design. For example, when I was working on biomechanical project of the cornea, and I had a lot of data in the devices which we were measuring the corneal biomechanics with. So the data which I had in those devices, and I had to export it. This is a raw data, so the raw data is the data before you put it in your Excel file, let's say like that. So the data should be assured during preparation, while it can affect the data analysis in the next steps. How to manage data? Data, when you prepare data, you prepare it in Excel file, and it can look like that. When in one column you have the patients, like numbering, and the variables are those parameters which you are describing in your project. And the goal is quantified speed sheet, most often with cases, down the columns and variables. So as you can see here, it might be age, test results, and follow-up, like preoperative, postoperative. It's just up to your study design. Data quality. It's very important. It's essential to verify the correctness of data entry at each change of data format, and again before beginning the analysis. Verifying data is tedious and boring, but very, very important. Because a busy, sometimes tired investigator might read a raw datum as 29, but type 92 into a spreadsheet, and failing to discover and correct such little errors could well weaken or even reverse the conclusion of the study. And in some ways, a worse outcome than losing the data, time, and effort altogether. That's why checking the data quality is very, very important for your outcome. There is also a term imputation or missing data. If a small number of observations are missing, they may be estimated one by one using of several technically defined methods, denoted imputation. Such a case might occur if a patient simply just doesn't come to the examination. When you need to put for example, describe the outcomes of 1 month's postoperative results, or 2 months, 3 months, not 2 months, 3 months, basically it's 1, 3, and 6 months. And you see that your patient just didn't have a 3 months outcome examination, but has 6 months. So how you can change it or just correct it? Just try to kind of manure with data measurements which you already have. If you have a measurements from 2 months follow-up but not for 3 months, then you can use on 3 months follow-up the data which was measured at 2 months follow-up. Or when you describe a 1 year follow-up, you can just and you don't have a 6 months examination of this specific patient, then you just can, based on the average parameters results, put the approximate 6 months parameter number in your specific data. But of course, if you just don't have any of parameters, then it's better probably to exclude those patients. But I'm talking about the amount of patients, when the amount of patients are not really high, and every patient is really important to have in your specific data. Keeping records. Absolutely essential is keeping a complete record of original data plus changes in data along with the reason for change. Make a disciplined habit of keeping complete records to avoid that thinking, feeling leading to desperate panic that arises when an investigator cannot justify data in composing an article or cannot to answer a reviewer's criticism. So it's very important to have your original initial data which you are getting from optometrist or someone who helped you to prepare the data before you start doing your calculations. It's like a court which you always have to have. Software for data management. There are different types of softwares, SPSS, JUMP, and StatView. I personally worked on all of them. My first experience was with StatView, then I continued with JUMP and SPSS. For me personally, I prefer to work on JUMP. I don't know, maybe because I have books from JUMP, and thanks to my supervisor who provided me with those books. But I find SPSS the easiest probably program for statistical calculation. But I think it's just an individual opinion. As long as you have a book which can help, or guide which can help you to do some advanced statistical calculation when you're already in an advanced level of preparing and calculating, then it's just up to your personal opinion which program is better for you. Let's talk now about basic steps of statistical analysis. So first you calculate the average, mean, maximum, minimum, standard deviation. Of course, it's not crucial to do all these things which I'm describing, but I'm sharing my own opinion and my own experience and what I find easier. So for me personally, this is like a basic step which you're starting with. Then you check the data distribution, and then you decide about the statistical formula. So let's talk briefly about each step separately. So first step, as I said, it's a calculation of average or mean, maximum, minimum, and standard deviation. This already I do always in an Excel file. Once all my data is prepared, all parameters are inside in my spreadsheet, and under the all parameters, it's like under the column, I just make an additional line for average, maximum, minimum, and standard deviation. So in Excel file on this top right, you have already average, maximum, and minimum automatic calculation, but standard deviation needs some formula which Excel file also provides. Second step, it's very important to check a data distribution, because based on data distribution, you will know which formula you have to proceed for statistical analysis. So there is a not normal and normal data distribution. But before, I want to mention about a few types of data distribution. There is a normal. So the normal distribution, as you can see that the pattern of this distribution is being shown with this bell curve, and this is a normal distribution which is as a standard normal, and which has mean 0 and the standard deviation which is equal to 1. But the statistical normal must not be confused with the medical normal, which in medical normal case. It means that it's not pathologic, but in statistical normal, it's just based on the standard deviation and the mean. Another type of data distribution is a chi-square. Basically, a variance is a sum of squares of values. If each comes from a normal curve, its mathematical pattern has a right skewed shape, and you can see this right skewed shape. And this distribution is called the chi-square distribution. And because all elements are squares, it cannot be negative. And you can see this curve to the right from the zero. Next is a T distribution. Looks like normal curve, however it's a little fatter from the side, as you can see, and standard deviation here is more than 1, not 1 as in case of normal distribution. And there is a F distribution, another type. The probability distribution for this ratio is called F after Sir Ronald Fisher, and is the ratio of two samples when the standard deviation of the data is bigger in probability than the other. And you can see the standard deviation is higher in probability. So basically, it's just I gave you just a kind of short overview what kind of data distribution you have in general. There are also, I pointed here just 6 data distribution types: binomial, there are also Poisson, and when I was searching in the internet, there are even more types of data distribution, but of course I don't want to put it here because we don't need that, honestly. But I just gave you the most common data distributions like normal, chi-square, T, and F, and yeah. And let's go back to this slide again. So the second step is, as I said, data distribution. And the data distribution might be not normal and normal. This is actually what we need exactly for preparation to statistical analysis. How we describe it, if it's normal or not normal, based on p-value. P-value in terms of normal distribution, it should be more than 0.005. And if p-value is less than 0.005, it's not normal. When you calculate in a software, of statistical software, a normal or data distribution, it also gives you like a question during calculation if you want to see this bell curve. I personally prefer to have it because if you have some kind of crucial p number, it's also good to see the Bell's curve, or vice versa. There are also scientists who just look at the Bell's curve and they estimated if it's normal or not. But it's better, of course, to have both. P-value is very crucial to see, to see which is if it's less or more than 0.005. And there are also normality tests, which I also showed in this slide: Shapiro-Wilk and Kolmogorov-Smirnov's test. Why I marked Shapiro-Wilk test? Because I've read a few articles and references where they say that Shapiro-Wilk test, normality test, is more reliable one. That's why I personally always check my data distribution with Shapiro-Wilk. And when I was a research fellow, I did a comparison between Shapiro-Wilk and Kolmogorov-Smirnov just for myself. I was checking a data distribution of one data with both of these formulas, and I end up with the situation with a condition when Shapiro-Wilk test showed me that the data is not normally distributed, but Kolmogorov-Smirnov showed me that it was normally distributed. But probably based on the references I've read, I went with the Shapiro-Wilk results, and until now, whenever calculations I do, I always check the data distribution only with this formula. And the third step is statistical analysis. So what we have to know when we start the statistical analysis also is a data set relationship. There is a paired or repeated data set relationship and non-paired or independent data set relationship. When we talk about repeated, it's basically when we repeat to measure one measurement, but with a follow-up period which are being changed over time. It's like for example, let's just make a simple sample. When I check a K parameter, a keratometry parameter after cross-linking treatment, and I check the preoperative, as you can see here, I showed it also, and then I check the same parameter after 1 week in the same patient, after 1 month, 3 months, 6 months, and etc. until 1 year, 2 years, 3 years, and up to your study. So this is a repeated data set relationship. Non-paired or independent, when you describe groups of patients, so 1 group, 2 groups, or compare more than 2 groups. So, and let's go to statistical calculation. For paired and repeated statistical calculation, it will be a student t-test or Wilcoxon test. Why I marked Wilcoxon test? This means that it's for not normally distributed. So now we understand why we needed to have a normality test, because based on the normality test, we know which exactly statistical formula we need to use in our data based on which data set relationship we had. So when we have a repeated data set relationship, the repeated measurement, and if the data is normally distributed, then we do student t-test. But for not normally test, it's going to be Wilcoxon test. And for independent measurements, for 2 groups and more than 2 groups, so for 2 groups, it's going to be independent t-test for normal distributed data and 1 Whitney U-test for not normally distributed data. And if it's more than 2 groups, for normal distributed data is going to be one-way independent measures ANOVA, and for not normal distributed data is going to be Kruskal-Wallis tests. Please don't be scared of all these names and all these tests, because software provides you with all steps how to measure them. As long as you put and prepare your data sheet in the way how it should be for their calculation. That was the description and guidance how to go from the study design to basics of statistics. I hope it was in a simple way described for you, and I hope you find it informative. Thank you for watching this video. I'm wishing you a good day. Bye.